We were asked to solve this equation, x dy plus y dx equals dx over y minus dy over x. We then group them according to the same variables, x dy plus dy over x equals dx over y minus y dx. Then simplifying, x squared plus 1 over x dy is equal to 1 minus y squared over y dx. Cross, we cross multiply these two. The result would be y over 1 minus y squared dy equals x over x squared plus 1 dy dx. We then integrate these two. U is equal to 1 minus y squared du is equal to negative 2y dy du over negative 2 is equal to y dy. Then v is equal to x squared plus 1 dv equals 2x dx. dv over 2 is equal to x dx. Substituting the values given a while ago, 1 over u times du over negative 2 is equal to 1 over v dv over 2. Then, negative 1 over 2 integral of du over u is equal to 1 half dv over v integral of this. The answer would be negative 1 half ln of u plus c is equal to 1 half ln of v. Substituting the values given a while ago, the result would be this. Negative 1 half ln of 1 minus y squared plus c is equal to 1 half ln of x squared plus 1. Then, simplifying this equation, ln of x squared plus 1 plus ln 1 minus y squared is equal to c. Applying e to both sides, e, the ln of x squared plus 1, 1 minus y squared is equal to e to the c. The result would be 1 minus y squared is equal to c over x squared plus 1. Then y squared is equal to 1 minus c over x squared plus 1. Y is equal to 1 minus square root of c over x squared plus 1. And this would be the final answer. The second problem that we were asked to solve is 2y prime minus y cubed cosine of x is equal to 0. Y prime is equal to dy over dx. Then we transpose this y cubed cosine x into the other side. And then we put it into the form of separable. Integrating this, we will have to raise y into negative 3 to simplify our problem. We then get 2 times y to the negative 2 over negative 2 is equal to sine x plus c. sine x minus 1 over y squared is equal to c. This would be our final answer. The third problem is y prime plus y is equal to xy squared. Y prime is equal to dy over dx plus y is equal to xy squared. This problem is Bernoulli's differential equation. We use u is equal to y 1 minus n. U is equal to y minus the power in here, which is 2. Then u is equal to y to the negative 1, which is equal to 1 over y. Du over dx is equal to negative 1 over y squared dy dx. Then dy over dx is equal to negative y squared du over dx. Then using the assumptions that we have made, which is dy over dx is equal to negative y squared du over dx, we substitute it to the real problem, to the real equation. Negative y squared du over dx plus y is equal to xy squared. We multiply the whole equation with negative 1 over y squared. Du over dx plus negative y over y squared is equal to negative x. Simplifying, du over dx minus 1 over y is equal to negative x. 1 over y is equal to u. So, du over dx minus u is equal to negative x. Getting the integrating factor of the equation that we have shown a while ago, v is equal to e to the integral of negative dx. Then v is equal to e to the negative x. Multiplying it to the equation, du over dx minus u is equal to negative x. The whole equation will be multiplied by e to the negative x. Then the result would be the derivative of this we use integration by parts. U is equal to negative x du equal to negative dx. dv is equal to e to the negative x dx. v is equal to e to the negative x. uv, which is negative x times e to the negative x, minus v du, e to the negative x negative dx. Negative x e to the negative x plus e to the negative x dx. E to the negative x times u is equal to negative x e to the negative x plus integral of e to the negative x dx, which is equal to negative x e to the negative x plus e to the negative x plus c. Then u is equal to negative x plus 1 plus c over e to the negative x. And u is equal to 1 over y. So 1 over y is equal to negative x plus 1 plus c e to the negative x. So y is equal to negative 1 over x plus 1 plus e to the negative x over c. This would be our final answer. We were asked to solve this problem. Y prime is equal to x plus y over x minus y. Y prime is equal to dy over dx. So x plus y over x minus y. By cross multiplication, x minus y times dy is equal to x plus y dx. Then putting it into the same side of the equation, x minus y dy minus x plus y dx. Since this is a homogeneous equation, we use x is equal to uy. So derivative of x is u dy plus y du. From what we have derived a while ago, this, we then have uy minus y dy minus uy plus y times u dy plus y du is equal to 0. Then we cancel the same, we distribute this, so uy minus y dy minus u squared y dy plus uy dy plus uy squared du plus y squared du is equal to 0. So y squared du plus uy squared du minus y dy minus u squared y dy. This is because we have cancelled some terms, uy dy here and uy dy in here. From this equation, we factor out the same variables, that is y squared times 1 plus u du plus y 1 plus u squared dy. Negative here. It's equal to 0. Then we transfer this into the other side, that is y squared times 1 plus u du is equal to y times 1 plus u squared dy. Then putting the same variables onto the same side, that is 1 plus u over 1 plus u squared times du, then y over y squared dy. We then cancel this out, so 1 plus u over 1 plus u squared du is equal to dy over y. From here, we integrate both sides, so it would be easier if we separate these two. That is du over 1 plus u squared plus u du over 1 plus u squared equals dy over y. So this would be then tangent negative inverse tangent of 1 plus u squared plus 1 half ln of 1 plus u squared is equal to ln of y plus c. So we will have here inverse tangent of 1 plus u squared plus 1 half ln of 1 plus u squared plus c is equal to ln of y. We apply e on both sides, so that would be e inverse tangent of 1 plus u squared plus ln of 1 plus u squared to the 1 half plus c is equal to y. So simplifying further, that would be inverse e to the inverse tangent of 1 plus u squared times 1 plus u squared to the 1 half times c equals y. This would be our final answer. In this problem, a particle of mass m along the x-axis is under the influence of a force which is directed toward the origin. And proportional to the distance of the particle from the origin. If the body starts from rest at a point where x is x sub o, find the equations which express its velocity and its distance from the origin as functions of time. So, x at o is equal to x sub o. This is at time t 0. So, x is equal to v times t because velocity is equal to distance over time. And so we have this equation. So dx is equal to v dt because as distance change according to time. So we integrate this. We have x is equal to vt plus c. So c is equal to x sub o because at the first distance, which is this, x sub o, x of 0, x is equal to x sub o, so c is equal to x sub o. So we have x is equal to vt plus x sub o. We have this equation as the answer.